In this video, I will demonstrate the interactive tools LeapfrogWorks has for numeric data analysis. Numeric data can be visualized and plotted using univariate and bivariate graphs to quantify numeric distributions and to support analysis and modeling of geotechnical domains from numeric interval and point datasets such as penetration tests, geophysical or rock quality designation data. The graph types include histograms, log probability plots, scatter plots, QQ plots, and bot plots. In addition to these graphs, there is also a table of statistics available. These graphs and statistics are available on imported numeric borehole tables, merged tables, composited tables, and points. While the statistics for an entire undifferentiated dataset can be useful at times, you will typically gain more valuable insight into geological and geotechnical environments if you focus on unit-specific statistics. Generally, imported interval tables don't contain both the numeric and categoric lithology data that would enable unit-specific statistics. Fortunately, LeapfrogWorks has the capability to combine separate interval tables into a single merged table from which you can calculate statistics independently for different units. I'll demonstrate how to create this new merged table and then discuss the available statistics and graphs in more detail. To create a new merged table, right-click on the Boreholes folder, then New Merged Table. I'll select the Geology and RQD UCS tables and click OK. This new table now contains geological and numeric data. Next, in order to calculate unit-specific statistics, I need to create a query filter for the units of interest: schist, sandy gravel, and granodiorite. To build a query, right-click the New Merged Table and select New Query Filter. Click the button with the small dots and build the query as follows. Merge Table 1, Geology, is schist. I'll repeat that process for the granodiorite and sandy gravel units. Now that the data is in a more functional state, I'll review each graph type, starting with histograms. To open the histogram, right-click on the column of data that you wish to view, in this case the UCS data, and click Statistics. The histogram has all the settings you need to understand the distribution of your data. The data is initially displayed using a length-weighted histogram, but you can also display the data as a cumulative histogram or a log probability plot. If necessary, you can choose to display the histogram of the log or view the x-axis by percentage. A box plot of the data automatically plots beneath the histogram, with different visualization options here. The limits of the plot can either be left as automatic and will rescale as the plotted data changes, or can be defined by setting the x and y limits. You will get the most value out of these tools when you take advantage of LeapFrog's visual and dynamic environment. We can gain an understanding of the data in its 3D context by selecting it in the histogram and simultaneously viewing the filtered information in the 3D scene. If I switch to viewing the geology column in the scene, I can see which units these high UCS values correspond to. They appear to be dominantly the granodiorite unit. If I'd like to analyze and understand the data within a particular unit or domain, like this granodiorite unit, I can do this using the Query Filter dropdown. You will notice that as the data selected to appear on the graph changes, so do the key summary statistics. To take advantage of this filtering functionality, relevant query filters must exist for the column of data. Next, we'll take a look at the scatter plot. To access it, right-click the table of interest and select Statistics. Choose the scatter plot from the resulting window. You can set the X and Y columns accordingly and log the axes as necessary. I'll set the point color to the rock unit, or alternatively, I can set a query filter to a specific unit to plot just that unit. Data on the plot can be selected using the selection tools in this toolbar, and the corresponding data will be selected in the 3D scene. Simply click and draw to select points to see the corresponding data in the scene. You can either replace the current selection using this tool or add to it using this one. This button allows you to remove points from the current selection. To remove the selection entirely, click here. Additional options include showing the weighted linear regression line as well as the conditional expectation. Next, let's take a look at the QQ plots and box plots. To open, right-click the table and select Statistics. This time we'll select the QQ plot. The QQ plots in Leapfrog Works can be used to compare theoretical and calculated values, or to compare values from different phases or styles of drilling. Using query filters I've previously set up for this project, we can compare the RQD data from the two phases of drilling by selecting the appropriate query filter for the X and Y axes. Next, we'll take a look at box plots. Use the first drop-down to select the data that you'd like to plot. In this case, I'll use the RQD data. Right now, we're looking at a single box plot for all of our RQD data. However, since we've plotted the data from a merged table that contains all of the lithology data, we can view the plots for each individual unit by using the category drop-down and selecting the geology column. Click Select All to view all of the available plots. By default, the plots are displayed using the minimum-maximum setting, for which the whiskers encompass the full range of values. With the inner fence option, the whiskers encompass the mild outliers at 1.5 times the interquartile range, and with the outer fence option, the whiskers encompass the extreme outliers at 3 times the interquartile range. Just like the other plots, a query filter can be applied if necessary. All geostatistical information in Leapfrog Works can be exported or copied out into your software of choice. In addition to these graphs, there is also a table of statistics available. To calculate your desired statistics, select the necessary numeric items. If you'd like the statistics classified by a specific category, add the category column here. Use the drop-down to select the appropriate category. The statistics can either be grouped by category, as shown here, or grouped by numeric item. By default, the statistics are length-weighted, based on interval length, but can also be displayed as unweighted if necessary. A query filter for the input data can be applied, and the columns being displayed can be edited as well. To tidy up the table, you can choose to hide the empty categories and inactive rows. Just like the plots, the data in this table can either be exported or copied out into other software.